Good morning. Thank
Um,
you for joining us today. For running a back-leveled ZOS is no longer a supportability concern. It's a confidence and trust issue. Of course, today we are talking about modernization. Before we do start this, I want to go over a couple notes. We are recording today's presentation. We will get an email out to you after the presentation is over with the opportunity to get a link to this recording as well as slides. If you'd like a copy of those, feel free to reply to the email and we can get that out to you immediately. We also would be happy to set up a one-on-one call or answer any questions through that email if anything is not gone over that you are hoping or expecting to hear today. Also, just reply to that email and we would be more than happy to get you any information you are looking for. Also, we do have Q&A available today. You can go ahead and pop in your questions at any time. We'll be making time at the end of the presentation to go over those. So don't wait to put them in as we're going through everything. Just know that at the end we will go over all of the questions that are entered throughout the presentation. With that being said, thank you again for taking your time to join us today. As I'm sure you all know, it is important to keep up with the operating system, as any unsupported operating systems aren't just a concern for support. They add additional risk, they complicate compliance, and of course, you don't get the access to the critical security enhancements that are available. And the challenge is not just getting to the next release, but getting there with confidence and trust. So, with that being said, I'm going to turn it over to Paul to get us started on today's presentation.
okay, thank you, Sammy. And I, like Sammy, want to thank all of you for coming out and joining us today. Um, if you're behind the eight ball on this, that is, if you haven't taken the steps that are necessary to upgrade to one of the 3X releases of ZOS, you're not alone. As of the end of March of this year, based on statistics from IBM, the whole community, the whole ZOS community was 27 months behind the update to 3X. And so that's a kind of historic cap, if you would, the highest I've seen over the last 35, 40 years. And surprisingly, roughly 10% of the community is currently out of service and 30% of the community will be out of service without taking action between now and the end of September. Um, those numbers are just unrealistic in today's environment with the number of feature and performance and security enhancements that are being passed through the IBM supply chain that need to be taken into consideration, particularly for testing and evaluation and ultimately rolling them into production releases of ZOS. So it's time to get started and it's time to move on. We really offer a set of tools that can help with that. Of course, many of you are familiar with image focus. Over the last year and a half, 2 years, we have been working to modernize image focus as a framework, providing several different entry points that you might think of as APIs that allow us to bring up various AI agents that can assist, specifically working with you side by side to help in any number of different ways. You may be familiar with IPL check AI, one of our agents that works in conjunction with the IBM Health Checker for ZOS to continuously monitor the IPL path of a specific LPAR image and report any given problems that might emerge, as well as any dynamic changes that may be taking place. Today, we're here to talk about zTuneUp AI, a companion to IPL Check AI. Essentially, with regard to our AI mission, our job here, as we see it, is to build practical rule-based applications that exploit the image focus framework In order to leverage its ability to retrieve information directly from the ZOS environment, characterize it in a number of different ways, and then provide sort of smart application of specific rules to each of the elements that are discovered in order to um, determine whether or not any of those individual elements might result in a problem or a failure of an IPL. This is done through conditional logic. You may have heard Steve Warren's presentation on AI on Z a couple of weeks ago, where he talked about the number of different applications that IBM is rolling out with its AI framework, with its AI model, excuse me. And one of those, obviously important on Z, is fraud detection. That is the ability to identify potential individuals who might be attempting to take advantage of the system. I want to be clear that this is not that kind of AI. What Steve is talking about is something that's a level above, certainly something that came after the machine learning techniques that were used to create the if-then conditional logic that is appropriate for our AI agents. What sets them off, however, uniquely, is something that's currently coming into vogue in the AI community, which is referred to as world AI, where large language models are being taught to understand their environment so that they can not only predict the next word that might appear in a series of text, but also to do it in the context of the environment that they're operating in. That is that ability to predict within the environment is a critical element of the AI agents that are being produced by Image Focus or with Image Focus by New Era. Our ability to use the Image Focus platform and its framework to actually discover the configuration, to allow us to understand that configuration in the context of a specific instance of ZOS is critical in the application of the rules that we have built over time to evaluate those elements that are discovered. No two configurations are the same. No rules are applied exactly the same in any given instance of one of our AI agents. It all depends on the environment that we are operating in. What we like to think of our agents is that they are rule-based retrievers. That is, that they apply specific ZOS rules to retrieve information from a given ZOS environment in order to arrive at a specific conclusion. At the end of the day, what these agents then allow you to achieve is a level of confidence that you are ready to go at any particular moment in time, and that confidence gives you the ability to trust what you are doing and to make sure that you can offer to your organization the confidence and trust that's necessary to move forward. So let's take a closer look at zTuneUp AI. What it's going to do is it's going to establish, using the image focus framework, that base configuration. And the base configuration, again, is a configuration that's specific to a given instance of ZOS. It's going to look at that configuration and attempt to discover any hidden elements in it that might result in some IPL risk or failure. It's going to identify any specific configuration changes that may be necessary, that you may be backleveled on, that you may not even be able to support with your current release. It's going to validate your upgrade readiness when you begin to move to a new release of ZOS. And it's going to highlight opportunities for improvement in the configuration so that you can reduce the risk in migrating to any of the 3x configurations that you should target at this particular point in time. So the outcome that we hope that you would think that has been achieved is that you've not only upgraded to the next release, but you've also done it with confidence and that you're ready to go into production. So how does it do this? Well, let's take a look at that exactly. Let me grab a pointer here if I can find one. Not having any luck just yet. All right, where'd you go? Yeah. The first thing that we need to give some thought to is what the image focus framework is really doing for us in this particular instance. It's looking at the running system that it's installed on, and it's going through the auto discovery of the full ZOS IPL path. And that not only includes ZOS, but includes JES, VCAM, and many other components that we'll look at shortly. What it next does, once that discovery has happened, is it passes that information on to zTuneUp AI, and it begins to apply the rules that are necessary for understanding that particular release. So given today's environment, it could potentially be someone that's at 2.4, 2.5, or perhaps 3.1. So the first thing that we do is discover the configuration, build a virtual environment of the configuration at the release level that you are currently operating at. We discover that or give you the opportunity to change that if you choose to, and then present those results in a review panel. And we'll see that in the demonstration. The third thing that it does is it does the same thing for a target configuration. So you might be running it at 2.4, 2.5, or 3.1, and your target might be at 3.1 or 3.2, whatever the case may be. Once it's made those two executions, it then compares one against the other to determine any changes that have occurred between those two when evaluated in terms of errors, warnings, and notices. An error in image focus is something that would absolutely prevent an IPL. A warning is something that might result in a brownout of the configuration, a loss of functionality at the end of the IPL process. And a notice is something that you might clearly want to clean up, perhaps an obsolete parameter of some kind or another. And the results of that comparison are presented in a comparison panel so that they can be clearly seen and hopefully understood with insight and clarity that may not otherwise be available through an examination or deep dive into the inspection traces. Here's what that panel is going to look like. We'll see that in the demonstration here in just a moment. At first, we're going to see, let's see what I'm doing. There we go. At first, we're going to see, get a pointer. We're going to see the source information. So the errors, warnings, and notices and exclusions that can be seen within the source trace that has been created through the inspection. Next to it, we're going to see the same information, but as it exists for the target, again, errors, warnings, notices, and exclusions. The source is 2.5 in this instance, and the target is 3.2. And you may be asking yourself the question, what are these exclusions? Well, let me explain. It's possible that in any running configuration, that is one that we discover and apply the current release of ZOS to in our virtual environment, may contain certain errors, warnings, or notices that have gone unnoticed for some period of time and might represent a distraction when you're attempting to upgrade to a new release. We've often said over time that before you can begin the move from your source environment to a targeted release, you need to clean it up. You might have data sets which are inappropriately protected. You might have situations where you have obsolete keywords, or you might have some syntax errors or whatever that are not impacting the actual running environment, but are impacting the fidelity of the configuration itself. And you want to say, okay, I recognize that those exist, but I don't want them to cloud my understanding of what it will take for me to move on to the next release. And that's what the excludes are intended to represent. You can see different levels of inspection here, the operating system, JES, what we refer to as ZOS aids. This might be something like the IBM Health Checker, it could be CSFS, VCAM, CICS, TCP/IP, and IPsec. If you select any of the inspectors, its results are expanded in the panel copy that's shown below, where you can see in detail the errors, warnings, and notices that appear in the source as well as in the target. Um, this visual comparison, that is your eyeballs looking at it and say, okay, I can see what the differences is in the messages and the counts that are produced for each one of these, the source or the target. And I can also see what is been excluded from the source or from the target if it's been excluded there as well. As we'll see in the demonstration, clicking on any of the white areas in this panel will produce additional results that allow you to drill deeper into what is being reported and let you do the exploratory data analysis that you should be doing as a data scientist using one of our AIs like zTuneUp AI. To get started with, however, we're going to begin with this panel. And this panel essentially allows us to define a source by either system name or by VM user ID, a target, again, probably the same name as the target we're comparing, but it doesn't have to be, but probably it should be, a release level, 2.5 versus 3.2, and then the selection of the various the various inspectors, OPSIS, JES, AIDS, PTAM, CICS, TCP/IP, and IPsec. And then as we see that information, we can begin to understand better what it is that we might exclude from the configuration itself. So let me stop sharing this now and move on actually to a demonstration. Let me close my window here. Okay, so now I'm in a 3270 environment. Let me open my window up a little bit. I logged on to this earlier, so I'm already logged on to an image, ZOS image, and I logged on as a TSO user, and I'm looking at the TSO primary menu. Now, those of you that are familiar with image focus know that there are a lot of functions that are available to you if you choose to set up the VCAM application in order to get to the ICE primary menu. To some, that has been somewhat of an inhibitor, and to some, it's been a step too far that's not required. Those individuals typically are running ICE BAT A or one of the ICE batch programs to do inspections, or perhaps they're working with IPL check and simply just turning over control of image focus to the IBM Health Checker for ZOS. One of the advantages of zTuneUp AI is that it runs directly under TSO ISPF and gives you full access to the inspection log for examining findings, in this case, findings as well as comparisons for evaluation against new releases of this operating system. So I'll go ahead and log on. It's a TSO application, so TSO, dollar, command line interface, comma, TUIDE. So here's that panel that I showed you earlier. And again, we define a source, we define a target. We can do it by ID or by VM ID if you would. We define a release target. So currently we're at 2.5, but we want to inspect it as if it were a 3.2 system. We have our various components in our inspection stack, the operating system up at the top. If we put the cursor under OPSIS and press enter, we'll see a somewhat unusual panel. Now, this is, for example, in the case of Jez, and we can see the messages. And as we press PF5, we'll simply scroll through the finding. So the best thing that we can do now is kick off a new finding. So we'll go ahead and kick that off. So here's the information that's being passed to the inspector. The VM user ID is ZOS25M. The release level is 2.5, and we've turned on these various components. But we're going to go through the discovery process now and the inspection process of our source configuration. Now, each one of these inspections, we're going to do 2 in a row. It's going to take about 60 to 90 seconds, depending on the complexity of the configuration itself and what inspectors we actually have turned on. What's happening here is that this discovery is being made dynamically of the configuration of the system that I'm actually logged on to. And each system is going to have its own unique configuration, its own parmlod, its own proclod, its own system data sets, its own RACF profiles and permits. Each one of them is going to be different. And again, the reason that we believe these AI agents are so powerful is because they're able to leverage the image focus ability to discover that and then inspect it on a unique and apply its rules on a unique basis, system after system after system. Another distinguishing characteristic is that each of the applications of each rules is fact-based. And so any finding that we have that might be in question can be traced back directly to a given rule, and the rule can be validated at that point. That is, you, as a decision scientist, perhaps raising a question about it, could just say, yes, okay, I see that now, and I believe that's correct. Or we could continue to examine it and adjust it accordingly with image focus, and then create a new release and make that available to the community in general. Now, much like image focus, if we turn on the function called index, we can avoid this if we wanted to, but I have it turned on. If we want to see the index, we'll see the index just as we see it in image focus. And so everything that we've been talking about that relates to image focus is also available here. So we can see all the parmlod members and whether there are problems or not. And we can see a number of different warnings that are being issued. And these warnings typically, in this case, have to do with protection being inadequate within the configuration as it relates to RACF and the profiles that have been created and our ability to comport with those during the inspection process. Critically important for discovering issues that might result in vulnerabilities. When I press PF3 and move on, the next thing we'll see is the inspection log data set that contains a trace of all of the components that were inspected in the inspection results. So here's the system name, here's the release level that we're inspecting at, and if I scroll down to the bottom, we'll see that this log of inspection results of their findings is actually 22,715 lines long. So in order to explore this content, to do the data exploration that's necessary in order to really understand what's going on, can be a daunting and somewhat difficult task. And this is one of the problems with image focus today, in that it's difficult to, in some cases, to understand all of the content and all of the hidden gems that are within the findings themselves. And so we are attempting to try to resolve that. By PF3 again, we'll now see an indication that we can continue. Oops, I went one too far back. Sorry about that. I have to start over again. This will take just a second. So one of the indications of how much content there is just simply to look at the size of the log itself. And most people today would tend to focus on just the errors, warnings, and notices, and perhaps overlook much of the content that's available in compliance reports as an example, or dynamic changes that are taking place in a given configuration as reported by the health checker, IPL check operating under the control of the IBM health checker. Sorry, I went too far back. This is a bit redundant here now at this point, but you'll appreciate what comes next. You notice down at the bottom of the panel on the right-hand side, it says index, and on the left-hand side at the bottom, it says trace. By unchecking those, index and trace, then those won't appear in the process of actual discovery and inspection that goes on when we select continue discovery. Coming soon. Okay. Okay. So here's our continued discovery. We'll go ahead and do the target now. Notice this one is the same same image, but now we're inspecting at a different release level, 3.2. These release level upgrade inspections tend to take a bit longer because there needs to be additional discovery for other things that might be required within the configuration for an upgrade to a new release. Of course, we need to make a change in the rule set in order to perform a correct inspection. Today, not like it was in the past, the release levels for the operating system and the release levels for JES and VTAM tend to be at the same level. That is, that we don't run dissimilar release levels as we might have done in the past, where we could run at 2, 1, and perhaps have a back level version of JES and VTAM, and we had different release levels that we had to deal with. But there is a possibility that we could be running a back level version of CICS. And if there is a more current version of CICS that is available, that currently is not actually being used, that is discovered by image focus, then a notice message is created that indicates that it's quite likely that it would be best for you to upgrade CICS to the latest release. So again, a certain, excuse me, a index panel is shown, and we can see this one's for the target and uncaped of the source. We can hit PF3, see the release level that was inspected is actually 2. And when we press PF3, then our compare will be done, and we'll be in our compare panel. Now, here's our stack again, OPSIS, JES, AIDS, VTAM, and so forth. If I put the cursor under JES and press enter, you see that now we have a series of white values that can be individually examined. So one of them might be, all right, so let me have a look at these JES messages, because there seems to be a lot of them over here that are indicating something. And those same messages were excluded from the source where they were viewed as a warning, but now they're being viewed as an error. And we have a look at that. And this is telling us what we need to know about that. We have full access to the log here, or to the trace, if you would. And so we can, if I can find the command line, where that command line to, and page up. Try to get an understanding of where this appears in the log. We can see the line number, we can see the message numbers. We can see everything that's necessary here in order to get a better understanding of essentially what's going on. We can look at things in perhaps a more consolidated basis. So here's a different error message that shows us just simply an invalid parameter and not the invalid detail line. We can PF5 through the report just to those messages. Of course, if you're familiar with image focus, you know that this will save a considerable amount of time in doing the analysis that's necessary to understand what's going on. But at the bottom line of the whole thing, it's still the same inspection trace that you would be examining. PF3 out. We can go to others like TCP/IP. We can see some warnings here. Again, in this case, we're just looking at inadequate protection of data sets, not appropriately protected by a profile. That's a no-no for sure. And we can also see that some messages have been excluded. These are things that were in our source that we wanted to exclude because we thought they would sort of gum up the works, but they show up both in the source and the target. And we can see what those are. Some parameters are exceeding certain limits. We can look at JES again in more detail. Obsolete keywords. More obsolete keywords. Things that just simply need to be cleaned up. If we look at CICS, Here we have a duplication of a subpar, something that will cause an error in CICS, as reported by image focus. And notice is reported by image focus, DFHSIP, possible system ABIN 047, AC1, but not APF authorized. So we have something that's a module that has an AC1 identifier, but it's not APF qualified. It's not in the APF list. Or something that's reported by CICS directly, an error in a parse function that failed, and then we can possibly see the line where the parse function itself did fail. If you want to, from here, you could send an email with the report included. You can put in your own message text if you want to. You can identify who the recipients would be. You can identify the security level you want to apply to the email. You can use SMTP by simply checking this box, or regular SMTP by not. So now we're back to our primary menu again, and from here we can continue to do exploration if we choose to. We can go back to the findings and continue to do that as well. So with that, let me stop sharing and return to okay, there we go. So as we get to the end of this, I think there's all kinds of concerns about AI agents, what they're capable of doing, et cetera, et cetera. It's not our intention, and I don't think it should be anybody's specific intention to build AI or AI agents that are targeted at replacing you as an individual. The need for a decision scientist, that is somebody who can actually interpret the results, whether that's through exploratory data analysis or that is working cooperatively with an AI agent, as we would expect you to do so with an image focus-based AI agent. Essentially, what the agent is doing is calling out and pointing to those items that it believes can be of a problem. And it's your job, essentially, to validate and work with that agent to rectify that problem if, in fact, it really does exist. If, in fact, there is a problem that was reported and it doesn't turn out to be a realistic issue, then reporting that to New Era technical support is obviously something that you would want to do. So, as Sammy mentioned at the beginning of this, the challenge is not simply upgrading to 3.1 or 3.2. The challenge is upgrading and knowing at the point in time when you think you're done that you're truly ready. That is exactly what AI, excuse me, zTuneUp AI is designed to do. To establish that trusted baseline through image focus, identify hidden risk, validate readiness, and deliver, and I underscore this, a simple outcome. Something that says, this is the way it was, this is the way it will be. What's the difference between the two? Do I understand that in detail? And if I do, I believe I can move forward with modernization and with confidence. Okay, well, let me just wind this up before I turn it over to Sammy, just to say, If you're already an image focused user and you're using one of the batch processes exclusively, or you're using IPL check AI in conjunction with the IBM Health Checker for ZOS, then this is a simple upgrade for you. For $2,000 in LPAR per year, you can achieve the functionality of zTuneUp AI simply by requesting a demonstration from a New Era Technical Support. If you're not an image-focused user, you should be. So ask us about our enterprise pricing. I think you'll find it economical and certainly worth the value that you will derive not only from image focus, but its various agents. So thank you again for attending. Sammy, I'll turn it back over to you to wrap this up.
Thank you so much, Paul. And thank everybody who joined us today. I know it takes a lot to get time out of your day, and we really do appreciate it. As I mentioned at the beginning of the presentation, this has been recorded. I will be sending out an email directly to each of you. And if you want to get a link to the recording, copies of the slides, or if you have any questions that weren't answered today, please reply to me and we will get you out all the information you need. Um, Thank you again and have a wonderful day.